Hi everyone, welcome back to the channel. Today we are starting our Electric Potential and Capacitance chapter from previous year numerical series. Now, according to the board exam blueprint, every year one numerical question is guaranteed from this chapter. So, if you understand these numericals clearly, you will definitely score that full mark question in your physics paper. So, in this video, we will solve three important previous year numericals step by step. And all these questions are straight from the real exam papers. So keep your notebook and pen ready. Let's get started. In this problem, we need to find out equivalent capacitance of this network as well as charge on each capacitor. And in this diagram, we have four capacitors of capacitance 9 microfarad each. And let me mark these are C1, C2, C3 and C4. And all these are equal to 9 microfarad. And you can see this A, B, C, D is one branch and E, D is another branch. So here C1, C2, C3 are connected in series in the first branch, that is A, B, C, D. So let me find first equivalent capacitance of this branch, that is A, B, C, D. So here they are connected in series, so that 1 by Cs. If they are connected in series, then we can use 1 by C1 plus 1 by C2 plus 1 by C3, this formula. Now we can see this 1 by C1 is 1 by 9 microfarad plus this is also 9 microfarad and here this is also 9 microfarad. This is equals to 9 microfarad, micro, I took it outside, microfarad, and this is equals to, this will become 3 by 9 microfarad. So 1 by Cs. So that Cs is equals to how much? Cs is equals to 3 microfarad. This is equals to 3 microfarad. This is a Cs of the branch A, B, C, D. But you see that this branch and this branch A, B, C, D as well as A, D, they are connected in parallel. If the capacitors are connected in parallel, then we have to add their capacitances. So that we can say the equivalent capacitance of this network is this equivalent capacitance of this branch plus the capacitance of this branch. The equivalent capacitance of this branch, how much? They are connected in series. Now let me take this one as Cs plus C4. So this is equals to Cs, how much we got here? 3 times 10 raised to minus 6, and C4 here we have 9 times 10 to the power 6. So that equivalent capacitance of this network is 12 times 10 to the power minus 6, or else we can take directly C equivalent is equals to 12 microfarad. Now let me find out charge on each capacitor. Here you can see this capacitor and these three C1, C2, C3 are connected in series, so that charge remains same across these three capacitors. So that the charge on C1 is equals to charge on C2 and charge on C3. This is equals to the equivalent capacitance of this Cs times the voltage applied across that branch, that is A, B, C, D. So here if you substitute Cs is equals to how much here? 3 times 10 raised to minus 6, and voltage applied across that branch is 300. So 3 is 900 times 10 to the power minus 6 coulomb. So this is equals to 900 microcoulomb. This is what Q1, Q2, Q3, that is charge on C1, C2, C3 is equals to how much? 900 microcoulomb. In the same manner, let me take Q4, that is Q4 is equals to C4 and voltage applied across this branch, that is AD. C4 equals to how much? 9 microfarad times voltage applied across this branch is 300 volts, so that we will get 2700 times 10 raised to minus 6 coulomb. This is nothing but Q4 is equals to 2700 microcoulomb. Okay. Let me go for the next one. In this problem, we need to find out the value of charge to be placed at D, so that the net potential at the center of the square becomes 0. That means to make the net potential at the center 0, what charge must be placed at the fourth corner D? That is the question. Let me consider that charge is Q. What is that charge? Q. We know that the potential at O is due to the charge placed at A plus due to the charge placed at B, the charge placed at C as well as charge placed at D, because the net potential we need to consider. The potential is a scalar quantity, so that we need to consider algebraic sum of all the potentials due to all the charges. So that the potential at O is equals to potential due to the charge placed at A plus potential due to the charge placed at B plus potential due to the charge placed at C plus potential due to the charge placed at D. So, now as per the condition given in the problem, we need to find out the charge which is to be placed at the D, so that the net potential should be 0 at the center of the square. So, V naught becomes 0 here. So, we know that VA is nothing but KQ divided by K, let me consider this one as Q1 divided by R1. So, you know that AO, BO, CO and DO are equal in the square. So, let me take these are all equals to R. So, we can take KQ1 divided by R plus VB. Let me take, instead of taking Q1, we can take QA, that is charge placed at the point A, and here we can take KQB divided by R plus KQC divided by R plus KQ by is R, and K and R are common. So, we can take it outside. So, K by R of QA plus QB plus QC plus Q. So, if I bring K by R this side, then it will become 0. So, we can take QA plus QB plus QC plus Q is equals to 0. On substituting the values, we get 2 here QA is 2 microcoulomb plus QB is 4 microcoulomb plus QC is 6 microcoulomb plus Q equals to 0. 2 plus 4 plus 6, 12 microcoulomb plus Q equals to 0. So, that Q is equals to minus 12 into 10 raised to minus 6 coulomb, or else you can take minus 12 microcoulomb. This much charge must be placed at the D to make a net potential 0 at the center of the square. Okay. Let me go to the next problem. In this problem, we need to find out the effective capacitance of the combination as well as the potential difference across each capacitor. And here we have the C1, C2, which are having the capacitance of 3 microcoulomb and 3 microfarad and 7 microfarad respectively, and they are connected, and this combination is connected to 10 volt supply. We know that whenever the capacitors are connected in series, the effective capacitance, whenever they are connected in series, the effective capacitance can be calculated by using this formula, that is the reciprocal of the effective capacitance is equals to sum of the reciprocals of individual capacitances. So, we can, or else we can make CS as a subject formula. So, that is what we can take C2 plus C1 divided by C1 plus C1 C2. If I take LCM, it will become like this. So, directly we can take now CS is equals to C1 C2 C1 plus C2, or else directly we can use this formula also. Now, you substitute the values, that is CS is equals to C1 here 3 microfarad times C2 7 microfarad divided by C1 plus C2, that is 3 microfarad plus 7 microfarad. This is equals to 21 times 10 raised to minus 6 divided by 10 times 10 to the power of minus 6. So, that this will become how much? This is equals to 10 to the power of minus 12, this is 10 to the power of minus 12. So, that this will become how much now? 2.1 times 10 raised to minus 6 farad. That is nothing but the CS is equals to, that is effective capacitance of this combination is equals to 2.1 microfarad. Okay. Now, potential difference across C1 and potential difference across C2 we need to find out. So before going to find out V1 and V2, let me find out the Q across this combination, or the charge supplied by the battery. Q equals to Cs and voltage applied across the combination, that is Cs is equals to 2.1 microfarad times this is voltage applied across this one is 10. So this is equals to 21 into 10 raised to minus 6 coulomb, that is what, 21 microcoulomb. This much charge is supplied by the battery. Now V1 is equals to, charge remains same in the series combination, so that we can say V1 is the potential difference across C1. So let me take V1 is the potential difference across C1, so that V1 equals to, here we can take V1 is equals to Q by C1. By using this formula we can take directly, that is we know that C equals to Q by V, so that V equals to Q by C we can take. So here V1 equals to Q by C1. So here Q is how much? Q is 21 microcoulomb divided by C1 is equals to, here C1 is 3 microcoulomb. So this is equals to 7 volt. V1 is equals to how much? V1 is equals to 7 volt. The same manner V2. V2 is equals to Q by C2. And here Q is equals to how much? Here Q is equals to 21 microcoulomb. 21 microcoulomb divided by C2. C2 equals to 7 microcoulomb. And here 7 on 7 3, so 3 volt. So that V2 is equals to how much? V2 is equals to 3 volt. So in this way we can find out the potential difference across each capacitor. Okay. Now try to solve the practice question on the screen and post your answer in the comment section. I will share the detailed solution in my next video. Thank you.